Why are you saying that? Why are you saying that, dude? Like,
I'm
you
not
see
saying
the
they
picture
do
I
actually
posted.
go up, but if I show you the picture I posted 5 over this hour, there is a couple ones that like go almost up, but they don't go up. They go over your head.
They're like almost perpendicular to your vertical, if not just slightly more than perpendicular to your vertical.
Yeah.
Is it possible?
Their actually path is actually perpendicular to your vertical. That's true.
Yeah. But being
But
We
they
should
appear
see
to
them
go up.
he's talking
parallel.
about them being parallel to your vertical,
We should
coming
see
up that way.
No,
once in
how
a
can they do
while.
that? Have
Yeah,
to
that's what I'm
come
trying to explain.
underneath
Hold on,
your.
guys. Hold on, guys. Once in a while, as I described it, the path of the comet or meteor or whatever, and your vertical will be parallel at some point. That should happen on a
Yeah,
globe.
you're right. Look at the picture I posted. I made this picture. There's a guy, the yellow guy. He's at that moment. He is exactly at the position you're talking about, where the meteors are coming in, are parallel to his vertical. He's not going to see them coming in though.
Hey guys, if I could just jump in for a second, we can continue the conversation. But yeah, I actually just I ended the regular live stream, and then we're starting up the Earth Awakenings live show. So let me just switch the event, start the event on the actual server. Okay, yeah, I just wanted to start it so it's got the right event. So yeah, welcome everyone to the Earth Awakenings live show. This is the 6th show that we've done. We did 5 of them in the end of 2021, and then took a break, kind of a hiatus over the holiday, and then we're going to start continuing the show. So yeah, this will be a show that we're running at 5 p.m. Eastern time, 10 p.m. UK, and then 9 a.m. Australian. On most days, we'll probably take some days off, but we'll do shows, several times a week at least, and depending. And I'll put up in the event, up in the upper left of the Discord, there's the little event page there. So when there's a show for the following day, it'll be in there 24 hours before, so that we all know there's a show the next day. Yeah, I wanted to mention too, just kind of as a review for this show. So we can basically run it in a couple different ways. I'll just kind of run over these kind of 6 general structures, and then we can decide what we want to do for today. So the first one is just, open topic, open discussion. The second one would be like to have like an actual set topic, but still be an open discussion. The third one would be kind of like short, either 1v1 or 2v1 types of discussions or debates. So in that case, like everyone else would be muted, and then it would just be, those 2 people or 4 people. And so, we can do that. We could also do like multiple of those, maybe 20 minutes for two particular people to be discussing, and then, another 20 minutes for 2 others, and so on. So there's options with that. And then the fourth one would be like a more structured debate, like an actual, structured debate. With like set participants and a set topic. And then the fifth one would be presentations. So different forms of presentations if people want to give, either long or short, however that goes, like either for an hour or for 20 minutes, and then we can always have like question and answer after that. And then the final one would be like an actual interview of somebody. So like interviewing someone, and in that case, probably most people would be muted during the interview, and then after we could do question and answer and that kind of thing as well. So, and then, yeah, just mention the last thing. If anyone wants to, either do a presentation or any of those things I just mentioned, like wanted to either offer, a topic or different types of, in terms of any of those, there's down in the Earth Awakening Support Center, there's a create a support ticket. So you can actually just click on that and then create a support ticket. And then, if you want to do a presentation or anything like that, and then we can schedule that for, the whichever show, whether it's in the coming days or weeks, whenever, we would integrate that in. So just want to mention that. I think for today, unless anyone has anything in particular, we could kind of just do an open topic, open discussion, just because we've been on a little bit of hiatus after the new year and everything from doing shows. So, but I'm open to we could do whatever the group wants. So yeah, so welcome everyone.
I'd like to be the first to say thanks, Gio.
Here.
I've been telling people for a while we should do some 2-on-2s. That'd be a good idea.
My
to have
shit,
a
dude.
segment.
So fucking full of shit, dude. Punch you in the stomach, man. Stealing my fucking shit, dude. You're like Scott Veach. You're like a mini Scott Veach, dude.
I don't know, Gio, but that was a pretty cool intro, if you ask me.
Cool, man. Thanks. I appreciate that. And yeah, it's fun to be able to kind of bring structure at a particular time like this that we can. There's a lot of options. And
You guys know Mike Tyson's a flat earther?
Is he like the paragon of fucking intellect, Jeremy?
Dead ass. He'll fuck you. I'll put anyone in the ring. Yo, get your best fighter. Put him in the ring with Tyson.
Fucking Garrett
all day.
Yeah, do you have the link to that? Because I had actually seen that I want to say a couple years ago. When was that? Because I know that wasn't recent, right? I've seen that in the past, but it's a clip of. I mean, Jeremy, do you think he really says he is? What he says is he says something like, how do we even know the Earth is round, man? It might not be round. He says something like that. But do you have the clip of it? Because he's on like a talk show, right?
Yeah, I did too. I just saw it on TikTok. I just found out a few days ago.
I remember this from a couple years ago.
Yeah, I remember it as well.
He was just saying it in passing. You know what you guys should use is Sherlock Holmes in the second episode.
I just posted it.
In the second or third episode, Watson was making fun of Sherlock Holmes because he doesn't think that the Earth goes around the sun.
We got another one that came out too, Lord Jamar. You guys know who that is?
No.
Yeah. He's a flat earther.
Yeah, I saw
Is he known for being
podcast.
clever, or what's he known for?
You guys see the
What's
ODD
Sherlock
podcast?
Holmes known for?
Yeah,
Hold on,
Sherlock
Matrix.
Holmes. What's this other guy known for?
He's known for doing hip hop. He was a mainstream hip hop artist
Awesome.
back then.
Awesome.
Yeah, I think he's a producer, and yeah, he actually was on the ODD. I think it's called the Oddcast Triple Truth that they're doing.
Okay. But is there any reason to put any weight on his opinion at all?
Yeah, because he has a brain and he can think.
He's very clever. He's very clever.
Here we go.
Yeah.
Here we go with the credibility bullshit. It always reduces to some sort of authority. It always reduces to that.
Okay, but who are you talking about though?
I'm fucking rapper that's a flat earther.
Lord Jamar.
What's his
He's
name?
been DJ Valid and all that. This
What's
guy
his
is
name?
known.
Whoever knows it.
I'll post him in the chat.
Yeah, Kosher, do you know about ODD's new podcast that he's doing?
No, I haven't heard about that.
It's like with David Weiss, ODD, and Sean Hibbler. Sean Hibbler is the producer who has made the documentary Level, and then there's another one coming out. I think it's called The Next Level. Those documentaries. So they do a podcast, the three of them. I think it's called Triple Truth is the name of it, and it's I guess it's Oddcast Triple Truth, and then it's on ODD's channel. And it's like the first hour is on YouTube, and then the second hour is on Rockfin, so they can not be censored. And they had Flat Earth Banjo on there, I think like last week, which was really good. And then this week they had Lord Jamar, and then Lord Jamar's brother. And apparently his brother is the one who kind of introduced it to Lord Jamar and kind of brought it to him essentially for him to look into. But yeah, I listened to the whole thing. It was awesome. I thought it was on point. I mean, like Lord Jamar was just dropping truth. Like it was great. I thought it was really.
He was also on the Killer. Hold on. He was also on the Killer Priest podcast.
Yep,
The
that's
guy
where I
from
met.
Wu-Tang.
Yep.
So Weiss is doing a good job. I don't care what his shield fucking degree is. He's doing a good job in spreading the truth.
Also, Wu-Tang forever.
Jake the asshole says he's a shill.
Oh,
you know what? I'm gonna tell you this, bro. Fuck Jake the asshole, bro. I don't like that shit he's on.
I'm just messing with
Dude, he's getting flat earth out there. That's the point. That's the purpose. This is Lord Jamar's YouTube channel right here.
Yeah, I get that he's famous and has a platform, but apart from that, why should we listen to him about the show?
I'm sorry. Who are you?
Dude, who are you? Why should we listen to you?
Yeah, who are you?
Exactly.
Maybe because you're a human being with a functioning brain. That's all. That's all requirement needed, right? Anything else is just bullshit created by somebody to get you to believe something.
Hey Ruhif, when are you gonna do your own? When are you gonna do your own fucking blink test for that stuff in Santa Barbara, dude?
No, you have to give me 2 frames to blink test. Otherwise, I'm just going to pick 2 frames that are identical.
Do it yourself.
Listen, Travis. If I pick 2 frames and show you how easily they are overlaid, you're just going to say, oh, because you picked 2 easy ones. Give me 2 of yours that you fucked up, and I'll show you how it's done.
Ruhif, all you have to do is find one of the videos.
Travis, literally just told you what to do.
Ruhif, all you have to do is find 2 videos that shoot the same target and just have them make sure that you've got them scaled correctly. That's all.
Yeah, and I've done it already in the video.
Oh, yeah, your own video has parallax, you dumb...
Yeah, vertical parallax, dickhead.
No.
Vertical.
No.
All right.
Yes.
No.
Yes.
Anyway,
it's
really easy. I don't know why. Like, all I had to do...
I agree.
All I had
I
to
don't know
do
why
was
you fucked it up so hard.
All I had to do is find 2 videos and get them to be about the same size because he's shooting video. So I just stopped the video when I saw that the landscape was about the same proportions and did a screenshot. It's very simple, Ruhif. You can do it yourself.
I agree. I understand that it's simple, and I've done it.
So do it.
All right. No, you have to give me 2 frames to do. The 2 frames that you fucked up, send them to me and I'll do it.
Oh, my God.
Otherwise, I'm going to choose 2 frames, and you're going to go, oh, those 2 frames are easy.
You know what we should do, Gio, is because I'm on the road right now, I can't do it. We should have Ruhif and me doing this shit in real time with on the show.
Yeah, exactly. We can do that. Like, you guys could do essentially like a 1v1. So and we'll let everyone know. So let's say, for the first hour of the show, and then, or the second hour, whatever you want to do. And then in that scenario, everyone else would be muted. And then if you guys want moderation, you can. Obviously, it'd be ideal if there's not talking over and all that kind of stuff, so we can hear both sides. But yeah, that way you wouldn't have to worry about, someone else jumping in and changing the topic. Like, if you really have something you want to be able to fully hash out, and then both sides can be heard by everybody, without other stuff coming in to intercept with it. Yeah, definitely do that.
So let me ask you real quick.
Just to be clear. There you go.
Let me ask you just real quick. Since I have 2 screenshots, are you saying that if I give you those 2 screenshots, you can match up everything perfectly?
Horizontally, yes. You didn't. You fucked it up big time.
Horizontally?
Yes.
And what did you say your parallax was?
Vertical, because Google Earth doesn't do refraction.
So so just to be clear, how would you orient something to eliminate horizontal parallax?
There won't be. If he's in the same spot, there won't be horizontal parallax.
That's
what I'm saying. You fucked it up. Yeah, correct. But because you failed to line them up, you go, oh, there's fucking horizontal parallax. Bullshit. You just fucked it up.
Well, let me jump in for 1 second. It sounds like I want to actually hear what you guys are fully saying. So maybe we should do a 1v1 at some, but I just want to mention real quick as well that I was quiet for a bit there because I was trying to get the link to the podcast, the ODD one with Lord Jamar. And it looks like ODD's YouTube channel is either taken down or something, because I do still have it on my subscription, but it's only got like only 1,200 subscribers, and there's only 2 videos on it. So it looks like his channel got something happened, and it's just recently.
Did you hit the actual video link?
I was just
go to the page.
Too.
Hit that where it says videos. Probably more come out.
No, that's it. It's just
I was looking too. I found the Killer Priest one. I found DJ Val. I found his podcast, Lord Jamar's, and his YouTube channel's still up. I can't find ODD.
Because I had to go to ODD's Rockfin channel, and then there I went to his links, and he linked it to the YouTube channel I'll post it, that I was saying that only has 1,200 subs. So something happened. Like he even changed the link, or it's either the same channel and all the videos got wiped and all the subs got wiped, or it's like a backup channel that he had. So yeah, something's going on there.
He's probably just using that channel for people to navigate from YouTube to Rockfin, because remember, Rockfin is like taking old videos and analyzes them to like banning people or suspending accounts for that. So
right,
that's why he did.
No, but he just the other day I was watching it on his channel it has like 330,000 subs or something, and then it has all the videos on it. He was just doing like the first hour on YouTube, and then they would go over to Rockfin. So something definitely seems to have happened.
Yeah, because I was just watching it yesterday, I think. It's not even in my history.
If anyone's interested in catching up to what Ruhif and I are talking about, I posted my video where I addressed his parallax and used footage for it.
Yeah, like partly I wanted to mention the ODD thing, but also the reason I jumped in with you guys is because it seemed like you guys were jumping into something that you already have history with or whatever's going on, and then I wasn't really up to speed on what it was, and then you guys went right at each other. So maybe we don't have to do a full 1v1, but yeah, if you want to at least kind of lay it out so we can understand what it is.
I've already said what I need to say. Travis can't align things horizontally, and he blames that for, I don't know. What's your actual point, Travis?
So you don't know what my point was in the video that I made for you to watch?
No, because you fucked up the alignment.
What should have been the primary point of alignment?
To compare the vertical positions of things?
To compare the vertical positions of... Okay, so what point in an observation would you choose to line up?
The horizontal stuff.
Okay, in an image, which part is horizontal?
Don't ask questions, Travis. Just fucking tell me your point, champ, all right? Just tell me your point.
You can't do a blink test.
Yes, you can.
My point is you, or not you specifically, blink tests are not possible over great distances when refraction is taken into consideration.
Yes, they are. My blink test showed where the horizon cut that mountain off. And the reason you think you can't do blink test is because you fucked up the alignment.
Did you watch my video at all?
I did. I got about 15 minutes in, I think. And you just kept fucking it up. I was like, what's the point? What point can you make with a fucked up alignment?
So, have you seen the other videos that Pablo has put out where you can actually see farther past that point that you consider the horizon?
And can you elaborate on how you think he fucks up the horizon?
Again?
Elaborate on how you think he fucked up the horizon so we can all understand what you mean.
No. Travis took 2 still shots from these videos, tried to overlay them, couldn't, and then, I don't know, made whatever point he thinks he made is that you can't do a blink test.
But why you keep saying that he messed up the horizon? But what do you mean by that? Exactly?
No, he messed up aligning them horizontally. So lining up, this mountain to that mountain horizontally, not vertically. You can't line things up vertically because you have different refraction.
Yeah, refraction affects the horizontal too, Rufy.
No, it doesn't.
Yeah, it does.
No, it doesn't.
Yeah, it does.
No, it doesn't.
Yeah, it does. Wow.
But isn't that the whole discussion to understand how refraction messes with the horizon?
I actually did some figures the other day, Travis. But if the vertical gradient was sort of mirrored sideways, you would have like winds in the order of hundreds of miles per hour.
Whatever, dude.
Yeah, whatever. Of course.
Yeah, whatever. Like, how is that even resembling reality at all?
It doesn't. That's the fucking point, Travis. We don't have winds at 100 miles an hour.
That means that you don't understand refraction. That's all that means.
Guarantee I understand refraction. It happens in the vertical gradient.
And the horizontal.
No, because we don't have strong enough gradient. If we had the similar gradient that we have vertical and put it horizontal, we would have winds in the order of hundreds of miles per hour.
Let me ask you this question. Does the vertical gradient due to refraction have winds hundreds of miles an hour?
No, because it's caused by gravity.
Oh my God.
Kept in equilibrium by gravity.
Whatever, dude.
Whatever. Okay, Travis.
What would be causing this horizontal refraction consistently?
Yeah, that's a better question. Thanks, Gosha.
Well, isn't there variation within the medium? I was surprised to hear you say that there wouldn't be. I would say there absolutely is. I mean,
it's incredibly tiny.
Well, I mean, there's a lot of noticeable effects on the horizontal that we get with the horizon. I mean, just one simple one. I'm not saying this is necessarily refraction, but just even when you're in an airplane and you can, this is something a little bit different. So I'm not saying exactly the same, but when you're in an airplane and there's like a lot of clouds on your left, and so you can't see, like there's a different distance at which the horizon shows up, and you get a different visibility. Whereas maybe over on your right, it's clear skies, you can see a lot further, and so on. So there's a lot of horizontal effects that are happening. So why would you claim that there's only vertical refraction and not on the horizontal as well?
I've said it 3 times now.
Yeah, twinkle, twinkle, little star. That's what they said. Sure. Refraction.
I think what Ruloff is trying to say is that the variation vertically is much, much greater than the variation horizontally. That's what I've understood.
Yes.
Right.
Correct.
It's consistent vertically, and if there is any gradient or change or whatever, it's not going to be a consistent gradient.
Yeah, and it will equalize itself with wind. That's what wind is an equalization of pressure gradients horizontally. And like I said, to mirror the vertical gradient and tip it on its side, you have fucking cyclones.
Yeah, whatever.
Whatever. Of course, Travis.
It is. You have no
substantive
science.
response, Travis.
Yeah, because you don't have anything deserving of a more educated response.
Okay.
I mean, it was a serious question though about what would be causing it. Like, what would be the mechanism that causes this?
Okay, I'm not going to make some bullshit answer up. You want to give me a team of people
Why not,
to go out
Travis?
there and do this investigation?
That's what you do all the time.
No, it's not.
It is.
No, my
you
observations.
All the time. Fucking ether band, Travis. Jesus.
Okay, the aether band is simply atmospheric refraction. So whatever the fuck you have a problem with the aether band is atmospheric refraction.
Why don't you call it that then? Refraction. Why don't you just call it refraction then, like everyone else? If that's what it is.
Because it is a specific counter argument against the accepted science. So I'm providing the details and the. Okay, hold on. Okay. I'm providing the details and the terms for which to provide counter arguments.
Okay. So, Travis, you just said refraction is a counter-argument to the science.
No, that's what you said.
I asked you what the ether band is.
No, he was saying that a more nuanced, more accurate understanding of what actually is occurring. Perhaps this is my representation of what I felt he was saying, because I am saying something a little bit different. But a more nuanced and detailed understanding of the actual effects of refraction and what is actually happening, and does that correlate with the mainstream scientific explanation currently? And if not, then what advancements and further understandings can we glean from it?
Doesn't ether band just represents atmospheric condition?
And it also includes the field of view in which you're looking. So it's not just simply the meteorology that you would consider as weather conditions. It's not simply that. It's making observations either in a wide angle field of view or a narrow angle field of view.
The idea of a band very much makes sense to me in terms of my direct observations. Like, the way like a rubber band, like you can have a rubber band when it's not stretched, it's a certain thickness, and you stretch it and it changes thickness. So, I mean, just in general, the idea of a band makes a lot of sense to me, and even sort of multiple bands, like the layers of bands. But and I mean, I'd like to hear more, how Travis sees that as well. But just that general concept of the way that refraction is happening at that horizon line and around that horizon line makes sense to me, that there's a band kind of.
What's wrong? What's wrong with Travis coming up with his own terminology?
Hang on. Because he's just fucking agreeing with scientific fucking consensus and calling it something different. Who gives a shit? Anyway, I'm at the shops. I'm at the shops. I'll be back in 20 minutes.
But it wouldn't be wrong though, Ruhiv. So what is your point of contention? Regardless of what he names it, it's still something that you acknowledge to be true. Then why bring it up to stop the conversation to that point? You understand what I'm saying?
I think he's saying there's no need to call it something different.
I get that. We all get that. That's what he's saying. But what would be the point? What would be the point of him telling Travis that?
Okay, so Kosho, if I were saying the exact same thing as the accepted science, I would be 100% behind you. Absolutely 100% behind you. I'm not. I'm offering alternative explanations, and therefore I'm providing alternative terms. It's not difficult. It's not a problem.
I mean, I asked you earlier for an explanation. You said you're not going to make one up. But, I mean, the reason why I asked that is because there is a mechanism for it that makes sense vertically. No, it doesn't make sense. It would be happening horizontally.
No, you think there's a
explanation wasn't for the ether band, though. We're talking about the ether band. Now, the explanation that you ask is for something else. You're conflating these two things.
So hold on, conversation that you keep butting into.
Okay, so Kosho, you have what you accept as a mechanism. I have yet to see any evidence that mechanism has been tested, manipulated, or proven.
You don't think
I would agree, or that the geometry of any globe is present.
All right, but you don't think there's a gradient in the atmosphere, pressure gradient and density gradient, any of that kind of stuff?
I think so. Yeah.
Would you like to provide evidence?
What needs to be proven then?
That's
the mechanism.
Okay, that's the same mechanism for the horizontal effect.
Yeah, but is there any evidence that there's a horizontal gradient?
Yes, if you watched my fucking channel, I have tons of evidence.
Oh, no, I mean actual evidence. Like the evidence for a vertical gradient is you can actually take measurements and see that there's a vertical gradient.
I have evidence for your side to consider. In fact, twice now with my conversation with the PhD from Georgia State University, he says to me, your evidence for horizontal refraction is still confusing to me. I'm not sure what to make of it.
Wow, so he actually accepts that you have something with it. Wow.
Yes. Okay. And when I tell him how I go about getting all of my data, he says, yep, you're doing everything right. That's exactly how I would do it. I've just never seen what you're showing me.
Did he tell you where you could publish it, maybe?
Yeah, he gave me an opportunity to write a paper for his website, and he would publish it.
I mean, like for a journal or something?
No, it's not for a journal. Hopefully this will make waves enough for it to go into that direction.
Yeah, they're not going to be able to deny it at a point. Although some of those systems have a lot of politics involved in terms of who they accept and what they publish, which is where it gets challenging, especially if it contradicts the mainstream.
Have you thought about possibly taking measurements to see if there's any kind of horizontal gradient? Because
if you would like to start a GoFundMe to raise money so that I can get a team of people to take off time from work, buy a couple of boats. Yeah, you do. Yeah, you do.
You have a barometer on your phone. You could just take measurements.
I'm on the beach. What about 20 miles away, Kosho?
Just take measurements wherever you're going and see if there's any kind of horizontal
Kosho. What about 20 miles away, Kosho?
Go to 20 miles away and see if there's a gradient there.
What about behind me? Now that changed.
Go wherever it is you think you need to go to see this horizontal gradient.
Okay,
but I can tell you that
so
for a vertical gradient, you don't have to go anywhere. You can do it in your room.
Well, Kosho, do you disagree that there is I'm going to call it a matrix, a horizontal matrix? Now, if you're talking about a gradient, because I know what you're trying to do with your vertical refraction is you're setting a specific gradient philosophy of a vertical thing that incorporates your curve, and then saying that's what's going on. And that's my summation of it.
I didn't bring up a curve. I brought up a gradient.
You have to in your refraction.
I don't have to. Don't have to, but there does have to be a gradient or some sort of obvious difference in densities for refraction to be occurring consistently. And it's not enough for there to be an instant difference of pressures, which is going to obviously create wind. But it would have to be something that was consistent, so an observation would be able to take place. For the light to actually curve like that, it has to go through several different boundaries for it to keep bending like that. There's nothing like that at all occurring horizontally to make that possible.
You have no evidence of that.
Exactly. There's no evidence that happens, and there's no mechanism for it, and there's no reason to suggest it.
That's because they know what they know, and they're not thinking about looking at what they can actually see and catch. Okay, so just like in Indiana Jones and the Temple and the Raiders of the Lost Ark, when Indiana and Sala realized they only had one side of the headpiece, they are looking in the wrong place. Okay, so you guys think you have all of the answers. So you're not considering other data. I have other data. Okay.
Well, I'm saying to you, all you would have to do would be to check even a small corridor, like on a beach or something, up and down the beach. Just check. The sea level pressure and see if it changes.
No, that's no proof of nothing. That's proof
yes,
of
zero.
It's
proof of a gradient or lack of one.
No, it's not, because if I go out and take a picture and I have a photographic demonstration of a horizontal refraction, and all of your data outside says I shouldn't, but I can show you that I do, then you guys have information about refraction that is insufficient or altogether incorrect.
Kosho, can I get clarification? You said light curves or bends. Which one did you mean?
I meant both of them, dude. And if you're that confused, I'm not going to be able to...
No, I'm not confused. So can you show me light curving, please?
No.
Can you show me light bending, please?
I cannot.
So you stated something. That
I'm not going to have a conversation with you, so I'm not going to do it.
Yeah,
I'm
right.
talking about something different. And you're asking me this like
no. These are questions that I have to.
Questions.
No, these are not elementary questions. I have these questions.
Elementary questions, man.
Go ahead. Well, then answer them. They should be easy.
I'm not going to. It's a waste of time.
Right. So they're pretty direct, right? I mean, if you're saying light's bending and curving.
Well, how about this? Why don't you guys show them that? Since we all know that this is what it's what's claiming to occur.
We all know.
We all know this is what's claiming to occur. We all know that this is what refraction is. There's no need to explain to him what refraction is. And if
you said we all know. How do we all know?
Kosho, we didn't ask you to explain anything. We asked you to show us light bending or light curving. And not a laser light, daylight. I've been asking for this for 3 years, and you guys are just shuffling your feet, whistling past the graveyard, just like you're doing right now, Kosho, if you're even still here.
This guy right here who's claiming to take pictures and show them to professors is also denying the fact that refraction is the bending of light in the atmosphere.
Show it to me,
and saying that
I'll
never seen it. He's never seen it. He's only seen it with lasers.
Show it to me,
I'm not going to do that. I'm not going to.
I haven't seen it in 4 years of research, Kosho. I've never seen any demonstration. I've only seen explanations and all this bullshit equations. I've never seen anyone provide a vision. And you know what is even more to the point? Why would a preeminent PhD draw a diagram of ray tracing instead of providing actual real-life natural footage? Because
that seems like a question for somebody else. Here's a question for you.
That's a good question. Real quick, are you talking about Andrew Thomas Young's website?
I am.
Oh, yeah, dude. I've looked over that. Wow. I mean, there are so many models, CGI, graphics, and virtually zero actual real observational evidence of these things. And then all these theories and explanations, a lot of them which require a radius value and other calculations. It's pretty surprising. It almost looks like it's like a it's like a mock website or something. You know what I mean? Like it's because it doesn't have the actual connection to the real life observations that he's claiming are happening.
Yeah.
Isn't he just using it as a teaching tool? Regardless.
Yeah, but shouldn't there be hundreds of observations to? I mean, where's he even getting the theory of it from? If not from the real world.
He's not trying to.
Oh, stop telling us you don't know
credit for it. He already has the. He's already has a teaching. He's already in the process of teaching people. He doesn't need to prove to people that he's what he's claiming.
Go ahead and White Knight.
But anyway, no, I'm just saying.
Is that science?
What you're saying, yeah. What you're saying is ridiculous. It's like
it's ridiculous.
It's like if somebody had like a chemistry class or something like that, and they were needing to show everybody like every single experiment that substantiated what they were doing, and they're just simply trying to explain things. Anyways, yeah, Travis, if refraction is not happening in the atmosphere, it's not bending light, then what is it that's happening in the observation?
Wait. Who said refraction isn't happening in the atmosphere? Who said that?
You're saying that you are saying that you've never seen light bending in the atmosphere. You've seen it in lasers, and I'm asking you, what is it then that you're observing, the pictures that you're taking?
I'm seeing a distorted image through a medium. Please show me light curving or bending.
Okay, this distorted image, how is it coming to you in this way? What is it that's distorted?
The image of the physical target in the distance is distorted by the medium.
Right, so it's the target's not was distorted, but the images, right?
You've been asked to demonstrate something, and then you've put it on somebody else to tell.
Yeah, I already denied you of that. I'm not going to do that for you. Okay.
Travis is taking fucking footage of inferior mirages and then going, "Show me refraction in the air, you fucking dickhead, Travis."
Oh, dude, let's.
No. Okay, hold on there, Ruhif. Whoa,
well,
settle down there, big guy.
To dial back with the insults and all that. I know he's trying to start a fight or whatever, but.
So
that's what I'm here.
Again, I've never said show me refraction. I've never said that.
Yeah, but you're saying show me light bending, and then I'm asking you, okay, well, if it's not light bending, what is this that you're taking observations of? You're saying it's just distortion.
Why are you
asking
me
to describe what this distortion is if it's not?
Well, let me jump in. What I heard Travis say is that the medium is distorting between you and that physical object. And now I don't want to speak for Travis, but that's what I heard him say. So,
right.
So let's just put this out there. The difference between light bending and the difference between the medium distorting something between you and a physical object.
Why is there a difference in that?
I'm just going to ask. Yeah, I'm just going to ask the room. Are those different or the same, or what are people's thoughts on that?
Hey, there's two ways of describing the exact same thing. The thing in between you and the observation is the medium. The thing that it's distorting is the light coming from the observation. The way in which it's distorting it is changing the direction the light is traveling. Like, I don't understand why, unless you're explaining this distortion in some other way. Exactly what you're saying. You haven't seen before is exactly what you're observing.
It would still require light bending because that's what the cameras are capturing. So if the image is distorted, then the light is coming from a different direction.
Show that it's bending, because I've never seen light bend. I've seen it change direction.
This is literally the point.
Bend.
Okay,
this is literally the point.
Light is entering the camera from an angle that is not the angle of the target.
So that's a straight line, an angle. You can only get an angle from a straight line. You can't get it from a bend, can you? From a curve.
And angles are just directions, champ.
I'm saying the angle it enters the camera.
A bend in
I'm not
light.
saying the path. For example, if I hit you with a car, I can hit you from a different angle. Doesn't mean the car made a straight path.
And how much light is going to be in that angle?
Okay.
How much bend is going to be there? That's what we're saying.
Well, if it's anything other than 180 degrees, then it's a bend.
180 degrees, no, it's a change of angle.
Yeah, I know, that's what I'm saying. If it's anything other than 180 degrees, then there's a bend.
You cannot get an angle from a curved line. It's got to be a straight line. It's like if you put light through salt.
Have you ever done calculus, champ?
It changes. But where is a bend in light?
Let me give an example of visualization. Like you see a car in a certain direction, right? And you close
Is
your
that
eyes.
light? We're on about light. We're not on about a physical.
It's just a
automobile.
visualization.
We're on about
just,
light.
It's a visualization. It's
No,
not. That's not an
a
argument.
car
It's
is
a
not
visualization.
light.
Yeah, that's not an argument.
How can you bend a car?
Well, not bending the car.
So a car travels.
Have you ever done calculus? Have you ever done calculus and measured the gradient of a curve?
What?
Yes? No? Have you ever done calculus and measured or calculated the gradient?
Oh, so we've gone
of a
from
curve
cars
at a
now to
particular
calculus.
Point? You're
So
saying that we can't
we asked
take
a simple
angles on
question.
straight-on curves.
Show me how light bends. We've gone from a car to calculus. So is the question going is the initial question going to be answered?
Let me
Right?
finish
And
the
Travis
point of the
takes
car.
footage of inferior mirages every day. That is refraction. How do you explain that if it's not refraction?
Is the original question going to be answered?
I just did.
No, you didn't.
Travis takes footage
Show me
of
how
refraction every
light
day.
bends, please.
Yeah, I have with Travis's footage. That's what he does all day.
By going through different index of refraction.
Where does light bend?
If light is entering a camera from a different angle than the direction of the target,
that's a straight line. An angle is a straight line.
Just
you can only have an angle from a straight line. That's not a bend.
No, incorrect.
You're not visualizing what I'm saying.
No, totally correct. You cannot get an angle from a curve.
Did you do any calculus at school?
Can you get an angle from a curve? Yes or no?
Yes.
Wrong. You cannot, because you need straight lines.
Then you didn't do
angles.
fucking year 12 calculus. Did you do calculus at all school?
Why are you swearing?
Because you're a fucking idiot.
There's no need. No, there's no
Relax,
need to
Rohit.
Come on, Jeremy.
Hey, what's the definition of an angle? Well, let's have the definition of an angle.
Oh, here.
I think it's a definition.
Difference in two directions.
Still don't want to answer the question. How do you bend light?
Different index of refraction.
I've never seen light bending.
Can I explain you why, if light is coming from a different direction, that it must be bending? You're open to the point. Can I make the point to you?
Go on then, please.
Okay. So you see an object in a certain direction. So you see an object on front of you, right?
Yeah.
And you close your eyes, and then that object hits you from the side, right? So it was in front of you. Then you're not looking at the object, and suddenly that object hits you from the side, not from the front of you. And that object hit you from the side by going on a straight line from where it was when you looked at it.
Can you bomb a hurricane to stop it?
That's a yes or no question.
What's that got to do with light?
Oh, yeah, but can you
Bacon, your mic is kind of going in and out a little bit. I'm not sure. It sounds like it's like under your T-shirt or something. But
no, it's not. Let me play with the.
I got a definition of angle. It says in geometry, an angle can be defined as the figure formed by two rays meeting at a common endpoint. The figure is an angle of an angle. And notice how it says two rays. Those are straight lines, right?
In geometry,
sure, yeah, one of the lines.
Well, that's when we talk about an angle, we're talking about we're talking about geometry, right?
Rohit was talking about calculus when he was giving his example.
So not geometry, angles, so we weren't dealing with geometry with angles.
No, those are angles as well, but Rohit's not wrong with what he's saying about the measuring a gradient and a curve.
You cannot get an angle from a curve.
We're not trying to get from a curve. The angle that we're referring to is the angle the light enters.
But we've gone off track. Can we get back onto the original question then?
That is not a curve.
Show me light bending, please.
Right. Yeah, I've got an example. Hold on, Bacon. I've got an example that I just posted in the chat. Can you look at that picture that I took and show me where light is bending in that, please?
Oh, you're talking about refraction?
Show me light bending in this image.
Let me ask Travis's. So Travis, those like windows on that building, looks like there's 4 of them. you know, up just under the roof line, the upper right part of the face. It looks like a building to me. Are those?
Yep.
There might be 5 windows. Are those in real life? Obviously, those are squares. I mean, they're not warped like this. So when you're seeing this bending, warping, whatever you would want to refer to it as, do you see that as the light is bending, or that the medium is causing the view? Like, how do you see that? I mean, is that bendy light right there? Because I think the globe earthers would say yes, right?
Okay, hold on.
No,
So,
not at all. No, not at all.
all right, so I'm pretty sure he asked me the question, so I'll just try to answer his question to me. So, the medium is distorting the image.
But if the light is coming from the sun and lighting up that building, and then the light is reflecting off that building to your eyes, which is why you can see it or why the camera could pick it up, is that, in your mind, is that light bending? The fact that's distorted?
Can you show me the light bending?
Well, the windows are not squares. They're all like bulged out and.
Yeah, those are distorted.
Can anybody conceptualize?
Hold on, Rakia, your mic's a little low, but
the medium, the windows are square. Get somebody near the house. The windows are still square. It's just the medium you're looking through from a distance is making it appear not square. The light's still reflecting back to the light is still reflecting.
What would be representative of light bending? How was that even observable?
It's not. It's all medium.
So the medium is, I would agree, the medium's distorting it, but is the medium causing the light to bend in your viewpoint?
Yeah, it's the medium. It has to be, because you cannot see light bending.
Okay, so here's how I would answer the question. Here's how I would answer that question, Gio. All I can see is a distorted image. I cannot see light being bent, refracted, curving. I can't see those things. What I can see is a lighthouse in an inferior mirage. The lighthouse keeper's house is in an inferior mirage. Those shapes have been distorted. That is what I can see. That is what I can say.
And how is it that you're able to see the image?
I don't think it bends at all.
Can you guys check the picture I sent on on the live stream text?
Yeah, the shit scientific ones.
Right. The drawing. I sent the drawing.
Oh, I didn't. I have you blocked, so I didn't see it.
You had me blocked?
Yeah.
That makes me sad.
Are you sure you put it in the right one? I said I had you blocked.
Livestream on text.
Oh, okay. Yeah, I do have you blocked.
Yeah, we see that. There's a light and a dude with a camera. Yep, looks like you drew this or something.
Yeah, just did. So can light of the light bulb enter the camera from the direction of the arrow by going on a straight line from the
It's all straight lines. It's just reflection.
Is that a yes or a no?
It's always straight lines. That's why you have angles.
Is that a yes or a no?
Angle of light. If you can't decipher if that's a yes, then you have the issue. It's straight lines, angles, reflection.
How could the light leave the light bulb and enter the camera, making a straight line, and enter the angle of the arrow?
Not making a single straight line. It's not making a single straight line. It's either reflecting off the sky or reflecting off a mirror or doing whatever.
Yeah,
angles. It's not curving around anything. Something's lifted up in your vision. It's not curving up.
Yeah, but it's angling from the light bulb, and it's entering the camera from above. So it cannot have been.
There's not enough context
by going a straight line.
You mean in your picture that you just drew?
I'm just asking if that happens, if that would prove light is bending.
No, it's reflecting.
Well, from what you've drawn here, if that's a light bulb, like that arrow you drew, like no, it's not. That image is not going to show up at that arrow. It's not going to curve upwards like a boomerang and then come down into the camera. It's all going to be straight lines. There may be the medium that might be distorting whatever you're seeing, but so I would say no, that you're not going to get that light bulb is not going to come in from that upper angle.
That's not what I'm asking. I'm not asking if you can.
Are
get
you
the
under
light
the
bulb
impression that because the light bulb is up, the light is going to go up and not into the camera?
No.
Why don't you show us? Why don't you show us a real picture?
Yeah, I don't get it.
I'm
The
just
light
trying
is
to
going up
agree
in
with
all
the
different
baselines.
directions in straight lines, including going to the viewer, to the
point that
camera.
I'm making, the point I'm trying to make is, if the light is entering the camera from an angle that is not the angle of the target, then it cannot have went from the target to the camera in a straight line.
Okay, show us what
Do
you
you
mean.
understand that?
Show us what you mean by a target not entering your eye in a straight line.
Sorry? What do you mean?
Okay, whenever I see something, like right now I'm looking out in front of me, I've got billboards to my left, I've got trees to my right, I've got cars in front of me. Okay, so my line of sight to this tree, the tree is higher than I am. But my line of sight to the tree is a degree. Right? But it's a straight degree. Everywhere I look is a straight degree in front of me. Everywhere.
What do you mean a straight degree?
If I have a house, if I'm standing in front of a house and I look up to the chimney, I have a direct straight line of sight to that chimney. And then I change the angle of my eye to the window below the chimney. That window is a direct straight line of sight. It's a straight everywhere I look on that house. If I look at every brick, if I look at every window, that's a direct angle to my eye.
Sure. But what happens? What happens if you're pointing a camera to the house? You're not moving the camera. You're not moving the house. So the camera can still see the house in the direction that the house is. After some hours, let's say, you look at the camera and now the house is like actually higher in the picture, in the image of the camera. So it's not entering the camera in the same angle it was entering before. So the angle that the light is coming from the house to the camera changed. And
no, it's still a straight line. It's still a straight line, no matter if it changed its elevation.
No, I'm not changing the elevation of the house.
No, visually you are. You said it's higher. So
yeah, it looks higher, but the house is still where it was.
I understand. Listen, you don't need to explain it. I understood what you said. I'm saying to you that even though the apparent position of the target changed in the camera's field of view, every point on that target is still a direct angle.
Yes, but you cannot have the position of the target changing with light still going in a straight line.
That's why.
If it was still going in a straight line, you would not have the target displaced.
That's okay. Well, I disagree with that to a certain extent, but that's why I don't believe that we see things, because light is traveling to our eye. Light illuminates the field of view, and I have eyes, and therefore I see what's out in front of me. If there were no light, I wouldn't see it.
Yeah, but
yes, I agree with that.
And
I agree.
Yeah, I'm using the example of a camera, and cameras work with photoreceptors, right? So that is light detection.
But there's a geometry that is consistent in my understanding of it. Like if you're standing or if you have a camera and you're looking at something, there is an actual real geometry between you and that object that is in the physical world. And then the medium would be involved in how you're able to see that. Just like, if you have like a bonfire and you look at someone like across the bonfire, above the actual flames, it'll be all warped because the heat is warping them. So in that example, they are really physically there. They're 10 feet away from you. You can verify that. You can measure it. You can have a third person that could verify while you're both doing it. That is actually there. But as you're looking at them, it may be distorted because of the heat. The heat might be causing warping or whatever it may be between you and that person. But but you're still physically in those positions. The physical position doesn't change. It's just the medium that that alters the actual way in which you're going to interpret whatever light is coming off the environment that is going to end up being received by your eyes.
Yeah, but it's still with the camera, with the example of the camera, the way the camera is formed a picture is by which position of the photoreceptors light reached. So if light is coming to a different direction, it's going to reach different part of the area of receptors. So that's going to make the objects be in a different position on the picture. If you're seeing the house or you're seeing the light bulb actually higher than it is or lower than it is, then to reach that's the different pixel of the camera, it must enter the camera in a different angle. So if it's entering in a different angle, that's no longer the direction of the target. So it cannot do that in a straight line.
Are you referring to the drawing that you did with the light bulb and the camera?
Yep.
But in your example, you know that a light bulb, the only thing that doesn't shine is the metal part in the bottom. Everything that's glass is technically reflecting. So it doesn't have to point. The light bulb doesn't directly have to point to the camera, because everything above the aluminum part that screws into the socket shines. So in your example, it will still be a direct line of sight to the bulb.
Yeah, I'm not getting it. Like, light is coming from the light bulb in all sorts of directions, and the ones that are going towards your directions is the ones that is going to hit the camera, and hit the camera sensor, and form the picture of the light bulb. And if that angle is higher, right? Go on.
Yeah, I mean, this is just ultimately a tertiary issue. Ultimately, because what we really are concerned with are the targets that we have disparate results when we're taking photographs. So the last picture I think that's in the chat is a panel of 3 photos that I took of the same target. Okay? And yet I have 3 different images.
Mm-hmm.
Light isn't bending, light's not curving. The medium is distorting the target.
It can distort without changing the direction of light.
You know what? Okay, look. If you want to geek out on that, I could give a shit, right? You know, if you want to try to break this down to its atomic level, I don't know why you would need to. But the issue here is that the reason why we have different locations of the horizon in different observations is exclusively 100% only due to the condition of the medium through which you are looking. The horizon is created 100% every single time, every single day by refraction.
Yeah, and the point is, you can only have distortions by changing the direction of light.
There you go again. You want to geek out. You want to geek out. That's not what I'm talking about. Okay, that's not what this is.
What is geek out?
The direction of light is constantly changed. The direction of light is constantly changed due to temperature or whatever night and day. Yes, you're right on that.
Well, I think what I'm thinking about the way Bacon's describing it, it's something I've thought about, like a difference between, like when they say the laser and the sugar water, like the idea of taking a laser, which is emitting light in its own way. I mean, I agree with Travis. I don't think light travels from A to B. I think it's actually an induction within the medium, but that's a whole nother point. But let's just say a laser that's inducing through the medium in that way, that you can get it to bend in sugar water because the sugar's refracting it and so on. But that doesn't mean that when we're in the environment that our eyeballs are laser beams and that our laser beam eyeballs are shooting over to something, or that the light is a laser beam that's coming to our eyes. I don't think those are the same thing. I think in the actual environment, you have the sun, which is essentially lighting up. Well, the sun's light is clearly illuminating the entire environment. And then you have a medium, and then you have the geometry of you between you and that object, the actual physical geometry. And then the medium is what's causing that. But these guys want to make a whole thing where light has to bend and your eye has to work like a laser beam, essentially, to make that bend and warp, to make the non-existent curvature somehow be explained away.
Listen to what you're saying, though, dude.
I agree with everything you said.
Your eyes aren't the laser beams. They're the antenna. Regardless, you guys keep describing the medium that's doing this, and there's a medium in between you and the target, and the medium is what's warping the image. In order for the medium to be doing that, it would make the medium a conduit or some sort of something's being transferred to you that the medium is obscuring. Otherwise, there's no reason for the medium, to be obscuring anything. It's obscuring the light.
What do you mean?
Your sensors.
Wait, hold on. So Kosho, remember the the old school windows that were made with imperfections in them, and they had all the waviness, right?
Yeah.
Right. So you're looking through the medium. The medium is distorting the outside observation, right?
But you're not going anywhere. You're looking outside. You're looking, meaning something's entering into your eyes. It's the light from the outside that's going through the glass and entering into your eyes.
The aether band is the window.
So can I ask what would be your conclusion if I'd done a certain experiment?
Can I just say something?
Right. Yeah, go ahead. Yeah.
I was listening to what people were saying, and somebody said that when the light goes from the atmos through the sugar water, it bends. It does not. It deviates. It does not bend. It changes direction. We've never seen
that's a good point. Yeah, I think I used the word refraction, but yes, it's being constantly refracted at each step of the way. I would agree with you. It's still straight light. It's just being changed ever so slightly by being essentially like the sugar is acting like mirrors. Essentially, that's creating that. It's like multiple mirrors that are reflecting straight light, not light bending. I would agree.
Have you ever seen a drag race? A drag race is a straight line back and forth. Have you ever seen a race where they don't turn and they don't bend their path? They just carefully change the direction they're going over and over again. Yeah, that's called a non-straight line. That's called bending. That's called curve. There's no need to
hold on.
No, they're trying to maintain a straight line.
I said this earlier. If you're going to measure how light bends in the fish tank, we're going to, after you're done with that, we're going to measure the top of the fish tank.
Whoa. Who said bend?
We're going to measure the top of the fish tank and then see how much the water.
Hold on one second. Hold on, man. Just let Jeremy finish if you could.
Okay, sorry.
After you're done seeing how this is how they do their experiments of how light's bending in the atmosphere. They do it in a little sugar tank. Fish tank, and they see how the laser beam bend. So if we're going to do that, after that's all done, we're going to measure the top of the water and see how much water curves when it's still. That ain't going to turn out too good for you guys, is it?
What does that have to do with what we're seeing?
Two birds, one stone.
Well, when you test how the light's bending in the two birds and one stone. When you see how the light's bending in the sugar water tank, right? We're going to see how the water bends on your globe Earth.
Can you show me water bending, please?
That's the point, dude. It's not going to be. That's the point. Jesus.
Can we stick to the topic?
Yeah, light bending, right? Talking about light bending. So how do you guys know how light bends? You do it in a fish tank, in a sugar water tank. Fish tank.
Let me ask something I wanted to ask Travis. So if I turn on a light bulb, then I have like a paper with a hole in the second paper, so the light bulb can illuminate the second paper through the hole in the first one, right? If I can change the medium in such a way that that spot of light in the second paper moves up or down, would you agree that the light from the bulb is bending?
I would probably say use the term refracting.
Yeah, but the light is not going in a straight line. If it was going in a straight line, it wouldn't hit a higher or lower spot.
No, that's not true. No, that's not true. That's not true.
How could it leave the light bulb in a straight line, and when it hits the second paper, it's actually hitting lower or higher?
That's called the angle of incidence, bro.
Yeah, which can't be a straight line for light.
It is a straight line.
So try to draw it. If you draw a line from the bulb to the hole, there's only one spot that it can reach the second paper. If it's not reaching that spot, it's not a straight line.
I can't make you understand the way I do, so I don't know what else to say to you.
In the laser experiment with the sugar water, right? You see the light bending down, but doesn't it still come out to the same side through the other side, right? It just appears to go like that because of the sugar.
No, it
so
comes.
You're telling me the point of the thing also goes down?
Yeah, if you they're showing it to you perpendicular, so you can see what's happening. But if you imagine you have a sensor on the other side, and you're shooting it straight, the sensor is not going to be receiving it's not going to perceive it as where the laser actually is. You have to move the sensor. So if you put the laser like in the center of the thing, you could be on the other side, and it might appear that the laser is actually at the bottom of the tank or the top of the tank.
Well, this is a very deep question. Does light curve in that? That's it's like, does it curve or not?
And also, does the medium force the straight line, right? Because like Kosho just explained with the sugar thing, if the actual point of the laser is going down with the sugar, that means that it's dragging the light source with it.
Yeah, that is the light. That is the path. Just like that's why someone tried to bring up a car before. A car is not what the analogy is. It's the path of the car. In this case, it's the path of the light. And yeah, the path of the light, it would go in a straight path if there was nothing stopping it. But because the mediums have different densities, it's a quicker path to make slight turns. If there's a gradient, then it's going to make enough turns that turns into something that perceives a curve, or something that looks like a curve.
So, Kosho,
did you just debunk your globe model, bro?
No.
So, Kosho, do you see that 3-picture panel? It's like 6 posts up.
I've seen it a few times, yeah.
Okay, so that was taken with the same focal length and set up in the same spot, so the distance is exactly the same. So, what's your opinion in terms of how this? I'm trying to think of how I was going to ask my question. I can't remember how I was going to ask it now. What was I going to ask you? This is okay. So as you look at each of these different photographs, the tree line is in a different spot, right?
Yeah, they seem to be not perfectly lined up.
Okay, and each of the angular sizes of the distant landscape is considerably different.
Yeah, it seems so. Yeah.
Okay, but when I walked out to take these pictures, I raised my eyes to the exact same 0 line of sight. Each of these images in my eye was in the same spot, directly in front of me. Not higher, not lower.
Done 3 different days, right?
Yeah.
3 different weathers.
Yeah, but my point is that when you look out and you see the horizon with your naked eye, the subtle changes to the position of everything out there can't be discerned by your naked eye. It just looks like it's apparently in the same position because all I have to do is look up straight ahead of me and there's the landscape.
It looks like 2 of those images have wildly different refractive effects, and one of them may have none or very little. But yeah, the one on the left looks like it has what would be, I guess, what do you call it? Inferior mirages, or superior mirages.
No,
Whatever one causes
superior.
mirroring, and then the other one has the opposite, the inferior mirages.
So, from what I can remember, the middle has no inferior mirage. The left and the right do.
Right, yeah.
Okay.
The middle one looks like it has the least refraction, if any.
Well, yeah. See, that's funny. It's like it's not the least because it's completely distorted and blurred, if you will. So that's massive refraction. Not only that, but we also have an extension of the water into the distance in the middle image. The image is on the right. If you look at the degree of angle from the buoy marker to where the water apparently stops, those are much shorter angles. But the middle photo, we see more water.
And you were on a boat?
No, I was on the shore.
On a beach?
Yeah, right on the shoreline. But what I want you to also consider is, so the middle image has that perspective triangle, right? That triangle represents perspective. So my suggestion is the very apex of that triangle is the shoreline. So when you go to the image on the left, you can't see the shoreline, but it's still right there in the same spot.
Wait, where's the triangle in the third image?
Probably didn't. I probably just figured that the two images on the left and the middle were enough to make the point, but the point would still be the same because you have that house. You got that black rectangle that designates the same house. That's the same house. So
all you gotta do is, oh my bad.
Yeah, Jeremy. Yeah, you're gonna say what I was gonna say. Go ahead.
Well, I was gonna say all you gotta do is get an actual position on whatever you're looking at, and you'll know if Earth's curving or not.
Oh well, that's not what I was gonna say.
Yeah.
But
nobody has that actual position, so when they say, "Oh, the light's bending like this," they're just making that shit up because they have no baseline. They have no actual position to go off of to know if the light's bending like that or not.
Well, you can see the refractive effects in the first and third picture.
That's got nothing to do with anything.
Well, it does, because if you can see the refractive effects, you can determine how the light's bending.
Okay, great. How is the light bending?
You need an actual position to know which way the light's bending.
Or you can have the evidence of if you have inferior mirages or superior mirages or phantom morganas or whatever, you can discern how the light is creating that image.
I don't think you can. I don't think you've made these kinds of observations. Otherwise, you wouldn't say something so silly. So look at the very.
Those observations they're not mysteries. They're understood how
no, they're not.
They appear upside down.
No, they're not understood. They are not.
Yes, they are.
They have explanations, but those explanations aren't necessarily correct. So look at the tree line. Okay, so the tree line does not have an inferior mirage.
Right.
Okay, so if you look at the very right image, the tree line is lower than the other two. Which way is the light bending on that one?
Well, it looks like that the light in the first image, you can see that the bottom part of the image is being refracted more than the top part.
Refracted what? Like refracted in what way?
I mean, the light it's curved more.
You see curving.
It's going to be curved more, which is why it's obviously distorted more.
You see curving light in the first image on the left.
Yes, that's how you get that image.
No, don't tell me how. Show me where this light is curving. Where is it curving, Kosho?
it's curving as it's going up. It's curving back down to where the dense air is. That's how that observation gets mirrored like that.
I don't see any curving light in that image.
Why do you think that it's being mirrored? Why do you think that there's being mirrored, being duplicated, the bottom part of that hill?
I can only tell you that I believe the medium is creating the environment that will produce an inferior mirage.
I agree with that.
That's all I can say. I don't have to say anything about light bending or curving.
Well, don't you want to make sense of it instead of just think that it's magic?
Okay, your explanation of light bending and curving is a magical explanation.
It's not. It's how we know things. It's how we know light to behave in mediums.
It's an explanation. You cannot show me light bending or curving.
It's not even light. It's not the only thing that behaves this way. Sound behaves this way in mediums.
Well, okay, this is a red herring.
Medium behaves this way.
Red herring. All I'm getting from you repeatedly is you cannot show me light bending. All you can do is tell me what you think is happening.
I can show you 100 ways that light, sound, water, any of these types of waves in any medium behave this way.
Okay.
This is what Snell's law is about.
Snell's law has fuck all to do with atmospheric refraction.
Really?
Zero. Yeah, zero.
Really? Wow.
Yeah, you want to know who says that?
Yeah, it actually it has everything to do with atmospheric refraction.
Okay.
You have to use the
wait for it.
Differential form.
Wait for it. So, I was saying this all along, but I was very surprised when I was reading, wait for it, Walter Bislin, who completely debunks Snell's law when making atmospheric observations.
Is he? Do you get your information from?
You can't use Snell's law for atmospheric refraction.
Yeah, you can. You can use the differential form of Snell's law. Yes, you can.
It wouldn't refract up a perfect image anyway, would it?
Well, not if you presuppose how the light's moving through the atmosphere, then I guess no. If you had an actual position and could show where if it was bending up or down, you might have something, but you guys can't do that.
Kosho, how do those rail guns aim?
I've never shot one of them. What do you mean? How do they aim? I'm sure they do it the same way all other ballistics do, and they know where their target is.
There's all this refraction.
No, they're not going to look through a scope and aim it. If that's what you think.
My understanding is that they do in certain cases. There's many that are line of sight.
Yeah, well, these ones, the railguns that we're talking about, the one that's on the Navy ship, is the only one that we have. And typically, when they use ballistics, which are not even going to go, which are basically shooting at a closer range, even a lot of the time, sometimes further. But either way, when they're shooting ballistics, they don't look through a scope and just aim and shoot it. They know where they're shooting and they know how far they have to shoot their ballistic.
How far is the ESSM shooting block? Well, I forget what block it is, but how far is that one shooting surface to surface?
Which one? Are you talking about the railgun?
I don't know. The Sparrow, Evolved Sea Sparrow missile.
Oh, I think it's I don't know. Surface to surface, I'm not sure. But is it only surface to surface or is it surface to air?
Well, this is a slightly separate topic, and we could go into that, but I just wanted to, I didn't want to cut that off what you guys were saying there, but I just wanted to. Well, I just wanted to say that just in my mind, I was thinking, because we were talking about with the light and everything, like there's two general ideas. One of them is you guys are saying the light is bending, and I understand you have to have that for the curvature and for all of the optical effects that we actually see on the Earth that are an extended plane. Something needs to warp that into the perceived sphere in your mind and in your models. So I understand that you need this curving light to be a thing, but there's another potential, which is that light actually does induce or travel in straight, but that it can get essentially refracted, which meaning that kind of like the pyramid, like, in the dark side of the moon where there's like the pyramid and then the one light comes in and then it refracts out. Like there's nothing curving in that. It's all straight lines of light, but the pyramid creates the refractive effect and creates that for other angles of straight lights to come out from it. So in that same way, the idea of like distortion, it doesn't necessarily have to be the light bending in my mind. It could also be that straight light is being refracted, just like the pyramid in the dark side of the moon thing, where it's being refracted. In that same way, it could be refracted in a way that ends up in your end result looking distorted, but that it isn't actually light bending. It's multiple straight pathways of light that are being distorted into your view.
How are those different things?
It's not.
What you said about us needing it for like the curvature. I mean, I've never even thought. I never think of it as needed for any kind of curvature. But what you said about the pendulum or the prism is exactly what that's what that's showing is the spreading out of the light, refracting light through that medium. That's exactly what's being displayed there. That's how. Most people.
Yeah, but you want to have here's a real mind bender for you. Are you ready for it? That's not how prisms interact with light, right? When you have a prism in daylight, you just have light hitting it from every direction. Daylight doesn't hit a prism in one beam or one ray.
That's what it's splitting up is. It's splitting up the light it's not splitting up light. It's receiving from multiple directions. The split beam you see is a beam that came in.
I'm talking about the source light hitting the prism.
Well, what if you did it, Travis, where you had like a black box or something, and you have a hole in the box, and you put the prism inside the box, and then you only let sunlight in through that hole? Would it then do that?
Well, yeah, I mean, I suppose if you, I don't know. So it depends on how close you are, because wouldn't it emanate in all directions once it passes through the medium that the hole that you drilled? It won't be a pin. It won't be a pinprick. The light will diffuse to a wider degree the farther away you are from the prism, right?
So actually, this is exactly how the first spectrometry devices were made. Were exactly like Gio described. The prisms and blocking off all the light, making like a little box, then putting the image on a wall.
It reminds me of that effect when eclipses happen, where you can get like thousands of little eclipse, like little solar eclipse slivers, that all like holographically reflect all over the ground and the trees and everything.
Yeah.
I mean, that's some process by which, like, it almost seems like the environment is acting as multiple prisms that are like refracting into. It's kind of fascinating as to why it happens during that, when the sun's light is being like potentized and mostly limited, other than one small section of it.
Yeah, I mean, I just think that a lot of the things that I've looked into, it seems to me that they are just simply
I think you cut out, Travis. Unless mine did.
No, I think it was.
Okay.
He might have had a bad connection. I'm not sure.
Yeah, he said he had a bad connection earlier. So yeah, Travis, if you can hear us, you dropped out.
But I mean, Joe, what you were saying though before, first of all, you strawmanned, but you did say it was what you thought. The reason why we do it or whatever, but it's not the reason. But what you said though, it's the same way that we think about it. That's exactly what we're thinking. That light does travel in straight paths when allowed, but of course, if there's a murky medium with lumpy densities and stuff like that, it doesn't have the opportunity to go in a straight path any longer, and it's why you see distortions.
Yeah, but distortions are different than something curving over 8 inches per mile squared to have it to where you can essentially see around the curve, but not not only are you seeing around the curve, but the image is being lifted up as if it's a planar surface. So there's a lot of, that's what you guys have. I mean, that's why you're defending, or, you know, you're purporting that light bends, is because you need that theory to fit into the radius-based refraction effects that you claim are occurring.
But I don't, though. That's what I'm saying. Every time you bring that up, bring up the curvature or whatever, I'm wondering who brought that up, because I'm not even thinking about it like that. I'm strictly
Andrew
thinking
Thomas Young.
about the principles of the light itself. The principles strictly of the
Andrew
light
Thomas
on
Young,
any plane, any earth or anything, any medium.
Listen, Andrew Thomas Young always invokes and describes the curvature of the Earth with refraction happening.
Yeah, but it's not necessary. It may be necessary in explaining how it propagates through the atmosphere and exactly how that displays itself. But it's not necessary to explain what refraction is and what the light is actually doing in any situation, whether it's in the water or in any medium, or the atmosphere. But just having to talk about the atmosphere, but it's consistent regardless of what the medium is.
Okay, so again, you can explain what you think is happening all you like. If you cannot demonstrate your claim, you have nothing.
It can be demonstrated. I've already said this to you. I can demonstrate it using not even just light. I can demonstrate it using any mediums. Any mediums. You can figure out the refractive index for any material. And it's going to be based on its and it's going to tell you about its density.
So do you believe that if you had enough information, you could predict what a target would look like on any given day?
Me personally, I probably couldn't, but I'm sure that there's people who know more. Yeah, there you go. Ruhiv would be able to do that. And I can give you a general idea, like if you gave me just the temperature, temperatures of different layers, I could tell you what it should look like.
Okay, so so if I'm standing on the shoreline of the Chesapeake Bay, how many layers would you like me to get?
5, but I think Ruhiv's probably a better person to ask.
No, it's fine. No. I trust your consideration enough to have a conversation with you. So, you said 5 layers.
Sure, yeah, 5.
Are all of these layers the same density? The same the same. Do they occupy the same area, same space?
Oh, like the same height, like the same thicknesses or whatever.
Right.
That's
right. Like how am I supposed to know? That's up to me.
Well, yeah, I mean, you're the one giving me the scenario. So
wait. So if I climb up 6 feet and then climb up 8 feet and then climb up 12 feet and then climb up 13 feet, you're going to take each of those different markers as an actual layer?
No, I'm talking about observation taken from one place. Just give 5 temperature or pressure gradients for different layers of the corridor.
I don't know what a layer looks like, Kosho.
It could be whatever height you say it is. If you tell me that 100 feet is all the same temperature, I'm going to give you a pretty good idea of what the refraction is going to look like.
So you don't need 5. I can just give you 1.
Sure. If you had one, and you just had one data set, it was just one consistent medium. Well, you wouldn't expect that much refraction at all.
Okay, so it's your opinion then that I could just assume that the target 20 miles away has the exact same temperature profile?
No, you wouldn't have to assume that. I mean, you'd have evidences one way or the other. If the weather was consistent, there's no wind.
How would I know? How would I know the temperature was the weather was? Yeah.
The more readings you take, the more accurate we can be.
Oh, okay, yeah. I'm talking to Kosho.
Okay.
So Ruhiv's going to know more than I do about this.
Yeah, but Ruhiv is not a friendly interlocutor. Okay, he doesn't.
I've changed. I've changed, Travis. I've changed.
Anyway, my point, Kosho, is that I don't believe that this is a simple observation or experiment or test, that you guys think that it might be, right? So getting all of this data is not a one-man show.
Sure, but I mean, there's other tools out there like weather balloons, and the data collected.
Yeah, and every single time,
make a thermostat string, Travis.
And every single time that I've looked up the data for the weather buoys in the Chesapeake Bay in my area, they're always down.
Okay.
So make yourself a thermostat string, Travis. Get like 5, pressure, temperature, humidity sensors. They cost you like $1 each. String them up on I don't know, 5-meter pole or something, and make 2 or 3 of them if you can. There you go.
Take a look at what the wind's doing and what the weather's doing and shit like that. You have a pretty good idea if there's inconsistencies between.
Listen, I get that. Listen, I don't necessarily have a problem with doing it in my proximity. I'm talking about the entire optical corridor that I'm making an observation on. Like, I'm not 6 miles away. I don't know what's going on over there. So when I was out on the Chesapeake Bay and I had a friend on the east side and I was on the west side, I had an inferior mirage looking across at him. He didn't have one looking across at me. What the fuck?
Yeah, that gets into like the idea of like a refraction matrix, or like the actual. There was another word that was in my head before matrix, but I was going to say refraction mapping, like that idea of actually mapping from multiple points the effects and then comparing. Like those may be things in the future that we could think about, like refraction mapping in order to actually map the entire, the larger matrix of what's happening.
Yeah, that's not too hard to do either. I used to make devices for ghost hunting devices for my friend's company or whatever, but you could basically use a cell phone, old cell phones. If you had a couple of old cell phones, that had barometers in them and stuff, you could collect, enough data. You can use that to help you collect data, but obviously if you had more information about the optical corridor, that would help too. But I mean, there's all sorts of stuff you can do to collect that information.
So in your mind, if I did collect the data for barometric pressure, water temperature, air temperature, that just tells me what the water temperature is. That just tells me what the air temperature is and the barometric pressure is. That doesn't tell me how the mechanism or how the medium with all of those realities together creates the image that I see.
Well, you could, if Ruhiv had that data, I'm gonna let him talk in a second. He could predict exactly what would occur.
More accurate data you get.
Well, since that was brought up, and since we're pretty deep on this topic, Ruhiv, you brought this up the other day on one of the live streams where you were talking about this, and we broke it down, and I walked through it step by step, and we were really digging down into in my opinion, and my viewpoint, of course, the assumptions, the calculations. But do you want to, removing my perspective on it, I'm just saying, do you want to present that? Because Kosho just said that, because you claim that you got this weather balloon data and then you did all of your calculations on it. Do you want to describe that?
Yeah. So my thesis over the last, 3 or 4 years has been, if you want predictable refraction, like something approximating 7/6R, then you need to get above the surface, because there is variable heat exchange between the surface and the air right above it. Therefore, refraction is very unpredictable. And it leads to things like the black swan. So in order to have a good approximation for refraction and therefore be able to do geometry, so like my usual example of if I'm standing on a mountain at 1,000 meters elevation, looking across to a distant mountain also at 1,000 meters elevation, I can calculate a very accurate prediction for the angle I should measure with a theodolite, knowing how much the light will bend. That's it.
Because you would use standard refraction, huh?
Yeah, because once you get above the surface, standard refraction's a pretty good estimate.
That's why I asked you about like if you give me the temperature layers, because that's what I would at least use being close to the ground is like what are the relationships between the temperatures and how close are they? If it's consistent, then I'm not going to think that there's that much refraction. But if there's cold, cold, hot, hot, cold, something like that.
Yeah. Oh, it's more about pressure
So
than
okay,
temperature, really.
so I hear both of you. I hear both of you representing things that I've only read. So when I look up 5 different sources on refraction and mirages, I will read exactly what you said. So all I'm saying right now is all you guys are doing is puking back what the rhetoric is. What I have not seen is how they know what they're saying is happening. I've never seen
Because
the
it matches
data.
reality.
No, okay, no.
Yes.
It's not that. Okay, it's not that simple of an answer. How do you know that the air temperature and the water temperature are the same, or even 1 or 2 degrees off? Right. So
what? For what observation?
Any observation. Okay, so let me ask you this. Do you know what weather conditions are necessary to produce sinking?
Yes.
Really? Can you provide a citation for that?
I can describe an inverse density gradient, yes.
No. I would like you to provide the science that is the basis for the explanation.
Yeah, light will bend downwards when the density gradient's inverted. And I can easily describe the density gradient. Yeah.
Okay. Again, all you're doing, why is this so difficult with you people? Simply because you can explain what you think is happening. Like you think that there's a density gradient inversion. Please show me that. Please show me a
I
density.
Can deductively.
Oh, you can just make it up in your head. Yeah,
No,
make it up.
I can deductively show you from lab-derived experiments that the air of certain conditions, so pressure, temperature, humidity, has a particular refractive index, right? And then you can just go and measure those conditions out in the real world and deductively conclude that it has an inverse density gradient.
Okay, so when you say measure those things out in the real world, okay, so fine, you don't have to do it right now, but I am honest to God asking you because I have not found this anywhere. So if you were the magic guy who found this information, please provide for me the laboratory data and then also the field data.
Yep. So the lab data is a paper from Siddor, Ciddor, and he's taken a whole bunch of other papers where they've empirically derived formulas for index of refraction in lab conditions. Can you not
give me a link? Can you not give me a link? I have a paper by Siddor, so I've
that'll be right.
I don't know, how many papers has he written?
Well, he's got one famous one. That'd be it. Okay. The index of refraction in air, right? For visual, visible, and near infrared.
So he addresses the issue of sinking?
No, this is purely to get the index of refraction, right? There's 2 steps to this. 2 steps. First step is to get the index of refraction. Second is to apply it to the atmosphere. And we get atmospheric measurements from weather balloons.
The index of refraction from what? The index of refraction of what?
The air.
And you consider the air in a laboratory to be the same as the air out over the Pacific Ocean?
100% yes. It has pressure, temperature, humidity, CO2 content. What else would you like included?
So you think that if I get a tank full of air in a laboratory and then go out over the Pacific Ocean, the humidity is going to be the same?
No, you fucking... Do you not understand the Siddor paper, Travis? Right? You input pressure, temperature, humidity, and CO2, and it gives you a refractive index. Right? Step 2...
You input. Who created? Wait. So you're telling me it's a program?
Yeah.
So someone programmed. Yeah. So someone programmed. Okay. So someone programmed the result.
No, they did a bunch of experiments and derived a formula.
There we go. See, that's what we were getting to when we were talking about it before. It's the right. So what's the formula? That's the thing. We need to look at every part of this because you're kind of saying things and then running over them. Oh, they plugged it in and they got this. Okay, what did they plug it into?
I don't understand the question. Say it again.
Well, if you're depending on this formula as being the basis for your entire perspective here, you must know the formula in and out. So what is the formula? Can you give that to us?
Oh, it's a huge formula. There's some basic ones. There's one called the Edlin equation, which is much more simple. But this one, the Sitter equation, is much more accurate for like 8 decimal places.
Do you personally understand them? Do you understand them?
No, I know that it gives the right result. That's all I need.
Okay, hold on. Okay, so let's stop right there. You don't understand them, but you quote unquote know that it gives the right result. Is that?
Yes.
No further
questions. That's the whole point of his paper.
Oh, man.
That is the whole point of his paper. If you give it temperature, pressure, humidity, it will spit out an index of refraction that matches lab experiments. You guys can call it reverse engineering if you like. I'm completely happy with that.
Just call it derping.
Okay, you can call it that as well. But if you give me the temperature, pressure, humidity, and CO2 content, I will give you an index of refraction, and it will be accurate to 8 decimal places.
No, I want you to predict what the target's going to look like.
Yeah, so give me as much data from the location as possible, and I will.
So this factors in the curve of the Earth?
Probably not, because it'll look the same pretty much irrespective.
But the index of refraction that you're claiming that this formula gives you, that you said, I mean, there is something to what you said there. If it matches what you said, quote unquote, laboratory experiments, I assume you don't know what those are or haven't looked into them. But if it did that,
the lab experiments. The lab experiments.
Yeah,
I've seen the lab experiments. They're in a lab. They got fucking interferometric refractometers, so they have light path through a vacuum compared to light going through the actual medium, and then they get an interference pattern and work out the index of refraction. Nothing to do with curvature Earth there at all.
Okay, so that's in a set environment, not on the actual Earth.
It's in a lab. Who's got background noise?
I'm probably chewing. Sorry.
Yeah.
Okay.
If you give me
I was asking if you, because you're the one sharing it, so I'm asking if you understood it. But I guess we kind of got to an impasse where you said that you don't know how the formulas work, and then you have maybe seen some video.
It's a matter of reverse engineering, right? Whatever numbers fit, that's all it is. Whatever numbers fit to give you the right answer. It's reverse engineered entirely, absolutely. I mean, if I can give you I'll give you the simplified Edlin equation. There's only like 3 or 4 constants in it, but those constants just happen to give you the refractive index. It's completely reverse engineered. That's fine.
Okay.
Those numbers, whatever the constants are, that's what they are.
I got you. I'm tracking with you, at least what you're saying. I would have to look into it all because that particular paper I haven't. So if you could post it or
Travis has got it. Sidor, CIDD. Actually, I'm going to park in a minute, so I will post it in a sec. Do you want a Dropbox link to the actual paper?
Either way, yeah, just post something. But so here's the thing, though. Like, this is what I then want to ask is because
can I get here?
If you have that refractive index that you're claiming that you've plugged in and gotten, how does that work in practical reality? And how for you does it link into this globe Earth idea?
Yeah, so then you apply it to actual measurements of the atmosphere. Go on, dude. Move forward a bit, dude. Thank you. Yeah, apply it to actual measurements of the atmosphere to get a refractivity gradient. And then you can work out how much light will bend.
Okay, so this formula is giving you the bending light, which gives the 8 inches per mile squared?
Not 8 inches per mile squared, no.
Okay.
It tells you how much light will bend.
Over that short of a distance, could we measure water over that short of a distance and tell us how much the water is bending?
You could, yeah. Yep.
And what are we going to get if we did that?
Well, if you get away from the surface, you'll get approximately 706R.
If we just measure how much, you're going to do this in a lab in a little fish tank, right? So we're going to measure how much the water bends over that short of a distance too, and how much bend are we going to get? How much bend are we going to get in the water over that short of a distance?
Immeasurable. Fuck all.
So nothing. So
yeah, because you're over fucking 3 feet, right?
Yeah, so you don't think this is too small of an area to be testing this on?
What?
Small of an area to be testing this on, how light bends in the atmosphere and how water bends. Both things are too short of a distance, right?
Are you referring to the lab experiments now?
Yes, the lab. We're gonna take get your lab.
So they do it
go in the
completely
lab.
differently.
Hold on, I'm answering you. We're gonna go in the lab. We're gonna see how much light bends in your little fish tank, and then we're gonna measure how much the water bends on top of it.
Right, but that's not what they do in the lab. Like I said, they have a device which has a flask of vacuum and then a flask of the air that you're trying to test. And the two paths of light interfere with each other at the end, and from that interference pattern, they work out what the refractive index is. Nothing to do with fucking measuring water over 3 feet.
I know you wouldn't do that because that's too short of an area to do it in. There could be,
correct.
It could be. Yeah, so that's what I'm telling you with the light bending over this short of a distance. That's too short. There could be other things at play that you're not taking into consideration.
No, when you're doing interference patterns, it matters a lot. The fucking size of the wavelength of light. Do you know how they work, right?
So you're claiming that what your understanding of the laboratory experiment and the refraction happens to fit 7/6R? Because you mentioned 7/6R. Is that what you're claiming?
Okay, so when you apply those lab formulas, which have nothing to do with the shape of the Earth, when you apply them to the atmosphere, you get a vertical gradient, right? Even that vertical gradient yet has nothing to do with the shape of the Earth, right? Vertical gradient, for anyone who cares, is generally around negative 0.000022. That's generally what it is, right? That's a vertical gradient, nothing to do with the shape of the Earth. If you want to apply it to something like a curve calculator, the way that you do it is increase the radius to 7/6R. That equates, fucking hell, I can't get a fucking park. Here we go. The way you do that is extend the radius so that you have a straight, hang on, reverse parking and talking. Can't do it. It's not going to be fucking big enough.
This is a convoluted, man. It's like formula, and then now you're adding in a radius. I mean,
some things are complicated, Gio. Some things are complicated.
It's too short of a distance to do it all. They're doing it over too short of a distance. There could be other factors at play that they're not taking into consideration.
No, I agree with that. Yeah, they haven't actually measured this on the Earth. It's all just small scale formulations that are being touted as being connected to a radius. But Ruhif, say the last thing you were saying. So bring in the 7/6R. Explain how you're doing that.
So when you apply that vertical density gradient to a curve calculator, right? The curve calculator goes, if the Earth has a radius of 3959 miles, then this is what we're going to see. All right. If you want to incorporate refraction, instead of going if the radius is this, you increase the radius. That's the effect that refraction has.
Oh my god. This is so convoluted. This is such a convoluted thing at this point, but okay.
Yes.
Keep going.
That's it. You apply 7/6R.
There it is. All right. So you've applied a radius that you've assumed.
Yep. Yeah. To say what if the Earth has this radius, what do we expect to see?
So, Gio, this is what I was saying before. Like, I'm gonna go whoever that is.
Hold on, Ruhif. Now you got a ton of background noise, Ruhif.
Oh, sorry. Hold on. There we go. Somehow noise suppression got.
So this is.
Yeah, it seems a little.
This is what I was saying before about. This is what I was saying before about starting over and doing flat Earth refraction, like. To do this from the ground up, been done, and not assume the Earth is a globe.
I think that the results would be 180 degrees in the other direction.
No. The density gradient that you measure, the vertical density gradient, does not give a shit about the shape of the Earth. Negative 0.000022.
Well, it does when you add in 7/6R.
Yeah, because you're applying it to a curve calculator. Then you're doing a what if.
Right. So you don't understand how that's an assumption.
It is for the sake of the argument. For the sake of the argument.
You're applying a radius to a planar Earth observation and the actual refraction that's happening. You're just applying a radius to it and assuming a sphere.
Whenever you guys, flat earthers, use a curve calculator to so-called disprove the curve, you are making the exact same assumption for the sake of argument.
Okay, but listen to what Gio said in case maybe you didn't miss it, but it sounded like you just ignored it. You are making an observation of straight line of sight observations and then curving them.
What?
Mathematically calculating a curve in them.
Curved light?
You're taking the actual observations on the Earth and then adding the calculation and the curve onto it into the presupposed model to try to describe. And you're calling that a prediction. It's not a prediction. It's really more of a postdiction because it's something that you're proving an assumed model from an assumed radius value into the calculations that you're doing.
No, I'm taking an observation and I'm saying what should I expect to see if the Earth is curved and what should I expect to see if it's not, comparing it to reality. I can do that before a prediction, before an observation if you like. Anyway, I'll be back in 2 minutes.
Yeah, I mean, like, what should we expect to see? Why would anybody say, what should I expect to see? That's just what we see. We go out and we see the island. We go out and we see the platform. We go out and we see whatever. You know, it's very simple to understand that if I can't see half of the house one day and I can see the house the other day, that it's the medium that's changing the observation every single time 100%, no matter what I see. No matter what I see. How hard is it to just leave it at that?
Because we understand it more than that, Travis.
No, you don't.
Yes, we do.
Okay. What is the one thing you understand that's more than that?
Because you're just going, oh, the medium changes it. And I'm going, yes, it does. We know exactly how it does.
That's all you need to know.
You're claiming it does along with the 7/6R with an assumed radius. That's just your.
That's the what if scenario, right? We're trying to see which model matches the.
No. Hold on. I asked a question based on something you said. You said you know more than that. Tell me one thing that you know. Tell me one thing that you know more.
Yeah, the density gradient causes a particular amount of curvature. That's more detailed than your explanation, right?
Wait, no. Where did you get curvature from? I'm sorry, what?
Light bends in a density gradient.
Okay, all you have is an observation. You see half of a target one day, and you see the whole target the next day.
Yep.
Where are you getting curvature in there?
I literally just said light curves in a density gradient.
Okay, can you show me daylight curving in a density gradient, please?
Daylight? Why does it have to be daylight?
Because that's where I look and see targets in the distance.
Okay, so every time you film an inferior mirage, you're seeing light curve. The end.
No, that's an explanation. You're not showing me anything.
I am literally showing. What do you expect to see?
Okay, so I'm just saying. I'm going to say it this way. It's refracting.
Yep, I agree.
Okay, but it's not. Okay, but it's not refracting downward, presenting the image up.
That's the explanation. That's what you are seeing.
That's the explanation. You can't demonstrate this. You cannot demonstrate or prove.
We're coming at it. We're coming at it as like I'm showing you what I expect to see if something is true. Right? You're coming at it from the opposite direction.
Wait, stop. when you say I can't remember how you said. Now if you think something is true, what you expect to see. Like
Yes.
I'm not starting out with any of those prerequisites. I'm going out to the Chesapeake Bay for the very first time, and I take a picture. Click.
Yeah.
The next day, I take a picture, set it up the same way, and the target is in a different location and has distortion. I don't expect to see anything. I don't have an expectation.
Yeah.
That's
but you
just the
need
way
to
it
come
is.
up with an explanation. You need to make some sort of inference or inductive leap to come up with an explanation, and then you go and test that explanation.
The medium. Yeah. The medium. Yeah, the medium is the cause for the displacement, distortion, refraction, inferior mirage, whatever. Yeah, very simple.
I agree, and that's an incomplete explanation.
Why?
Because it doesn't go into the actual detail of how it causes it.
Actual detail, neither did you. You just said light was curving. When I said show me, you said look at the picture. The light's curving.
No,
that's no.
We have a density gradient, and we know how the density gradient curves light. We know it has different refractive index. There is far more detail than just the medium causes it.
You have no field data to base these statements on.
Yes, I do.
You have no, I'm not talking about laboratory data.
No,
I'm
neither am
talking
I.
about
said field data, and yes, I do. I've analyzed over a fucking gigabyte of weather balloon data to show that when you're close to the surface, refraction is highly variable. When you get away from the surface, it's quite predictable and approximates 7/6R. Anyway, I'll be back in 2 minutes.
Well, yeah, since there's a little bit of pause. Yeah, yeah. I mean, in general, this is about a 2-hour show. We can go to 2.5. Then there's the after show. So basically, once this show's over, I'll close out this stream, create another stream for the after show, so we can continue the discussions. We went a little bit past 2 hours because that seemed like that needed to be completed. So yeah, but we can perhaps start to wrap the show up and then just head into the after show, or we can continue all the discussion. But since you were about to say something as well, so yeah, we'll just run through and anyone who wants to do final thoughts. So Travis, if you want to go first, go ahead.
Yeah, I mean, I just wait for the other shoe to drop in terms of whatever. Did I mix the metaphor? Whatever. There's going to be something that is said that is going to.
You're roboting, bro.
The crack. Okay.
Yeah, it was like lagging and roboting. If you want to try again now, or someone else can go, and then you can come back once your connection's better.
I want. What are we doing? Final statements? Closings. I just want to say these guys are doing this thing over a few feet in a lab. There could be other effects that's causing the light to bend in different ways. Okay, we know magnetic fields can cause light to bend. We know that magnification can cause light to bend. Their own guy, Andrew Thomas Young, even says there's fucking atmospheric magnification. So it's not even a guessing game. We know shit shrinks or compresses as it gets near the horizon. Like, shit's not staying the same angular size even. So it's not a guessing game. That shit's going crazy out there. They think they know everything. In the meantime, Ruhif doesn't even know what K stands for, what the K stands for in his refraction formula.
Cool. Thanks, Jeremy. Yeah, it was definitely very in depth on that one topic today. Anyone else? Just kind of open to anyone else that has any other final thoughts. Feel free to jump in, or if you didn't weren't able to say something during the show, now's the chance. So yeah, anyone wants to jump in? Yeah, Riven, I just got your DM. I just unmuted you if you wanted to say something.
Yeah, is Coach still there?
I think so, yeah. Well, he's in here. I don't know if he's unmuted.
What up, Brummy?
What's up, Brummy? You all right?
We're good.
Someone talking to me?
I heard people talking about fucking Astra meteorites going different directions.
Well, we're hold on. We're running through the final thoughts for the end of the show here. Ruhif, your mic was unmuted. Do you have any final thoughts before we end out the show?
What was not really.
Okay. Anyone else?
They don't have any actual positions on objects in the distance. If they did, then you could prove that the light's bending and we're seeing it a certain way or whatever from where its actual position is. They never have an actual position though.
I would agree. And in terms of being able,
I've got a thought.
In terms of being able to validate that, I agree. That's what would be needed, and it's non-existent. Go ahead.
All right. So Jeremy said, light doesn't bend, whatever. Regardless of your assumption, if you assume a flat Earth, do the geometry and assume that light doesn't bend, and tell me what angle you should calculate for some distant object, and then measure it.
Bro, we've already got Eratosthenes to work on a flat surface. All you got to do is change the way light's bending, and you could have it be on a flat Earth all fucking day.
Not with 3 observations, you don't.
Yeah, all right. This is final closing statements.
Yep.
All right. Yeah. Anyone else have any final thoughts? All right. Cool. So yeah, we'll just close the show out here, and yeah, thanks everyone for a great show. It was definitely very in depth on this particular refraction topic, but I thought it was great, and I was able to think about things in new ways. So that's always good, and for myself. So yeah, I appreciate that, and I appreciate everyone being here. And like I said, just check the for future shows up in the events tab up in the upper left of the Discord server. You can check there for when there's going to be a show the next day. And for those folks listening on YouTube, all of this is run through the Earth Awakenings Discord server. So it's free to join for anyone. And you can just click the link it's in the description for the video. So there's a link to join the Discord server. And if you don't have a Discord account, you just have to create a Discord account. They're like a social media company. And you can just, with an email address, create an account, and then come on into the server, and you can join the panel and join the discussions. We do live streams that are running, all day and all night. So there's always live streams running, and then we do this Earth Awakenings live show as well. So you can come on future shows as well. And so thanks everyone. Appreciate great show. And I will. I'm just going to stop the stream and then start up the after show so we can continue, and then we'll run into the after show. So thanks everyone, and see you on the next show.